Okay, we are on chapter 17, topic 17, current and resistance. Let's share the PowerPoint, and they start off with looking at a superconductor, and we're actually going to skip the section. It's section 17.7 on superconductors. If you're interested in them, you're welcome to view it. There's nothing about superconductors on the MCAT as far as I know. So I'm not going to spend time on it. I think most of you are interested in the MCAT, passing the MCAT. If you are interested, please take the time to look at section 17.7. I'm not going to take time to pursue that in this lecture or give you any problems related to it. So let's go on. Okay, here we have a cross-section area A, and we see charge. We see positive charges moving from left to right. And that's how we define current. Current is positive charges moving in a direction. The direction I is what we define as current is positive charges moving along, let's say a wire or down a beam, let's say like a cathode ray beam, something like that. So it's as charges pass through an area in a given period of time, that's how we define current. So the average current is equal to delta Q over delta T, the amount of charge over a particular amount of time. The SI unit for current is the amp, or it's coulombs per second. So 1 coulomb per second is 1 amp. So I is equal to the limit of I average, which is the limit is delta T goes to 0, delta Q over delta T. Let's see. So here we see it's actually electrons that move through a conductor. But you can see negative electrons moving actively to the left is equivalent to positive holes migrating to the right. So we think of current as positive charges moving in one direction. It's actually the electrons that are moving in the opposite direction. And as the electrons move, they leave a little hole, and the holes actually migrate. And it sounds kind of funny, the holes moving, but that's the way we think of it. That's how we define current. You can see at the bottom it says temporary positive holes in the atoms of the conductor. In other words, an electron has left the atom, and so it leaves a positive, basically a positive ion in the atom. And so as the electrons move in one direction, the positive holes migrate in the opposite direction, and that's what we call current. It's an unfortunate assignment, but that's what we live with it. Okay, so now in electrostatics, the electric potential is the same everywhere inside a conductor. That's no longer true. As charge moves along the wire, the electric potential is continually decreasing. So the decreasing electric potential means that the moving charges lose energy according to the relationship delta U of the charges is equal to Q delta V. And an energy of delta U of the wire, the electric potential in the wire is equal to minus Q delta V. The energy is being deposited in the current carrying wire. And that's it for this section. We'll stop the share and we'll go on with section 17.2, a microscopic view of current and drift speed.